It's also important to have an idea and a little bit of historic background as to how extrasolar planets were discovered and the progress over the last few years. It turns out that people have been trying to find extrasolar planets for many, many years, and this effort grew specifically from the 60s to the 90s, where a lot of teams actually claimed that they had discovered planets and then realized that that was not the case. Now, even though technically the first planet was discovered just before 95, it was actually not discovered around the normal star, but it was actually around the pulsar. This is the reason why 95 is really the date where we say that we discovered the first planet, because this was around a normal star, a star named 51 Pegasi. This was done using spectroscopy, the Doppler method, or radial velocities, and you can actually see the discovery data here. It is very clear that the radial velocities imply that the star is moving with a specific period. And it's just that this period was really surprising because it implied a planet of sort of the mass of Jupiter that was within an orbit that was closer than Mercury is. At the time, a lot of people were skeptical of this discovery, but a lot of observations were done by many other astronomers, and this was firmly established as a planet that has a period of 4.2 days. That's how long a year is in this planet. It has a roughly circular orbit, and it has a semi-major axis that is incredibly small. That's 0.052 AU, and if you compare this with Mercury's semi-major axis, you really understand how close this planet is to the Sun, even though it is almost about half the mass of Jupiter. So it's a Jupiter-class planet that's in an orbit that's way, way inside the orbit of Mercury. And this discovery was also recognized with the Physics Nobel Prize in 2019. And in 2017, we even discovered the presence of water in the atmosphere of this planet. In 1999, people discovered the first extrasolar planet using the transit technique, again with very surprising findings, where this star that's named HD 209428 was found to dim by essentially 1.7% every 3.5 days. This again indicated a presence of the planet that was about 60% larger than Jupiter, but on a very, very inner orbit, again, closer than Mercury is to our own sun. It was then possible to actually use the radial velocities to measure that the planet had a mass of about 60% that of Jupiter. And by combining the size and the mass, it was actually discovered that this planet had a density that was much lower than water. And the consensus is that this planet and many others like it are actually gas giants. They've been sort of puffed up by the heat from the star. But as we'll see, it was really puzzling to explain how can you have a planet like Jupiter actually forming or existing so close to its own star. Perhaps one of the big revolutions came with a space telescope named Kepler that allowed the transit method to really deliver on its promise. Kepler was in space for a few years, and he was actually tracking almost 150,000 main sequence stars all the time, measuring very precise photometry to look for any dips. Kepler really revolutionized the field because, as you can see, from 95, where the first one was discovered, 99, where the first transit was discovered, the progress was still going relatively slowly. Radial velocities really picked up with ARPS, but when Kepler arrived, it was just a boom of extrasolar planets. And this was just in 2014. And nowadays, we have over 4,000 extrasolar planets discovered and confirmed.